to know about it and give a little bit hint about what we did.
Okay, we're recording now.
Okay. In this part, we are discussing the IMU sensor, this one, with ROS serial and Arduino. The code published, here is the code that's running on the Arduino. Here is the code. This code use the transformation package from the ROS serial, the standard one, and the sensor message IMU. And there is a child frame and the base frame to link the transformations from the IMU frame to the fixed frame. These are the registers in the IMU that the values from the I2C communication is captured from them. All this part, and this is a part for the calibration and some filters. The filter this is merged from many parts. The man who wrote it is this one, and this man, and he managed to write the part for fusion using the gyro and the accelerometer. And finally, I use this part to send to publish to the IMU message topic using these equations. And this part for the transformation using quaternions. Quaternion, as you know, is for quantities, one for translation and the other three for the three rotations. And all this is broadcaster. The broadcaster send it to be broadcasted the ROS. And here is the part in the ROS. Here is it. The publisher to the message the TF topic, and link that to RVS using this command to run RVS base link. Now, when RVS is launched, I just add a transformation that is here to that is listen to the transformation message, the transformation topic, and move the IMU according to this motion. There is still a little bit error in the reading after all this calibration, but I still working on it. That's all the last part. Thanks to Allah. Open the voice, Matt.
You want to show the IMU moving in RVS?
Yes, it is it. Open for Omar also. His voice is not.
That's good work.
Thank you. It is.
Nice. There is still some error during the calibration, but let's see the values, the IMU topic itself.
Here is the values. The angular acceleration from the accelerometer and the gyro values for angular velocity. This one can be used for the navigation stack as one input to the navigation stack. Do you want to see the big picture from the ROS rover? This one from the University Rover Challenge? Do you remember it?
Which one was that?
The ROS rover for the University Rover Challenge.
The soil sampling?
What?
When it was doing the soil sample?
No, the ROS rover, that one. I will show it to you.
Is it competition?
Yes, a competition for university called University Rover Challenge. But they published their software on GitHub, and they have a picture for all the software block diagrams. I refer to it when I want to link or everything. Their project was very complicated.
The Daniel Snyder?
Yes. I will share the screen for it. Here it is. It did you see it? Are you seeing it now?
Yep.
Yes, here is IMU. You see it?
Yeah, I see the IMU there.
Yes, it's publishing to the navigation stack part. This part is a Kalman filter that fuse make global localization and local localization to publish to the navigation stack. But the navigation stack also can take the input from the IMU directly. But this part link these two packages link are a Kalman filters to fuse the data. And I am working now on this. I have a link for the wheel encoder. That's awesome. A package for Arduino ROS serial odometry that send odometry message. I will share the link.
Daniel Snyder stopped by one of our meetings and gave a presentation on the ROS rover. I posted a link. Daniel Snyder, that made the ROS rover, he came by one of our meetings and gave a presentation. So I posted the link in the chat file so you can watch it. He goes through the packages they used and how they set that up.
Okay.
They did a really nice job.
Yes. I like their software block diagram. I refer to it when I want to link many things together. You will share these links after the meeting in the Slack, sure?
Yes.
Okay. Here is the GitHub link for the ROS serial odometry with Arduino. A simple package for an optical encoder, one channel optical encoder that can be used for odometry. What is asked? I still working on it also. I am asking Allah to help us to finish the IMU and the GPS, also the odometry by the end of this week, if Allah allows.
On that simple ROS Arduino odometry, does that fuse your wheel encoders and your IMU?
No. The encoder only. Take the readings from the Arduino using ROS serial and publishing on the standard odometry this message. I don't remember its name, but it's use the standard message for odometry to publish the x and y and theta, the rotation about z for the robot. This can be linked with the IMU as they did in the ROS rover, or you get it directly to the navigation stack without the use of the Kalman filter. I don't know is it right or no, but I will Google it and learn more about this point. Had you worked on it before?
I've worked with odometry.
With linking the odometry and the IMU in the navigation stack, have you worked at this certain point?
Yes.
And what did you do in that?
Like in that chart from Daniel Snyder on the ROS rover, on the local EKF, you fuse the IMU and your wheel encoders, and that gives you your local position, and then you run another EKF to fuse all three together.
Can you get this data directly to the navigation stack?
What the navigation stack uses is odometry, so it's listening for an odometry message.
Sure.
So you need a couple. You need to make that odometry message. And one way
message contain all the 6 information.
Some people, they use robot localization.
Okay. I thought that I read before that the navigation stack can take the IMU and the encoders directly. And the LiDAR. In the standard one, it takes LiDAR. For the turtle boat one, it takes the LiDAR and the... I will open it. Anyway, I will learn more about it and to take the right route. والله لا. That's it from we graduated.
Good job. That's progress. Looks nice.
Thank you. Thank you. Tell me more about what you are working on now.
A couple things. Been working on this small microcontroller to read sensors and then see if that can replace the teensy board. We're working on redesigning the electronics. There's a lot of noise on our electronic boards. So on tonight, Howard, they from Virginia Tech University, they won the AgBot Challenge this year, and he's going to give a presentation on their electronics and how they reduce noise
Today?
on robot. Yep.
They will make this presentation today?
Yes.
Okay. Do you have any question in the doodle?
Yeah. So, are you going to run the? Are you going to run move base and everything on Doodoo, or is the plan to run that from the base computer?
On the doodle, if Allah allow.
Okay. That's nice. Looks good. Strong robot.
That's a villain that I told you before to mixing simple robust.
Yep.
Here is our ear. Yes.
Yes.
And to start get more fishes from the ocean.
Yes.
And you have, I think you saw the articulated steering, but we didn't tell people more about it. The robot, the railway robot we saw before, we see before. Did you remember it?
With it had a joint in the middle. The wheel spun. That's the way it turned.
That robot was in Germany for railways. The small ones that you liked.
Is that a possible design for Doodoo?
We made it really.
Oh,
We
already.
made Doodoo have the articulated steering to separate to give more control to the robot and flexibility.
Good. Nice improvement.
And this design achieve more is more efficient to reduce the power loss in the friction when the robot is turning using the skid steering or the differential that's known as differential wheel drive.
That will allow it to drive around the field better, get into more places.
Yes. When we tested as As you see in the video, we managed to we were testing the algorithm, the computer vision algorithm to detect the row, but not turning. Next time, if Allah allowed, when we complete the user interface to start select the start point and the end point, the robot sure will be turning to enter a new row. I think this will be great, and the robot will be good maneuver if Allah allowed.
That's exciting.
Thank you.
It's good progress. That's a lot of work.
One day.
One day.
And that day is approaching.
Yes.
Here is now I am sitting in the headquarters of Al Jazeera, our startup. We are now graduated and we are working in our startup.
More of these quarters will open in Silicon Valley.
One day, also
Yeah.
one day.
And that headquarter will be Al Jazeera, Egypt,
Yes.
and the other in the Silicon Valley. And we will visit Matt there.
Yes.
Inshallah.
That'd be fun.
Yeah.
Thank you very much.
Thanks.
We have a couple people that are working on area coverage. So they'll kind of have a boundary shape, and then it'll automatically plan where you want the robot to go. That can be a hard problem. There's a lot of edge cases or fields where it doesn't work very well. If you have a perfect field, it will work, but there's still
Did
some.
you see there is a robot from Honda, a lawnmower, a robotic lawnmower from Honda?
Went 100
Have you
miles
heard
an
about
hour.
it?
It goes over 100 miles an hour in 6 seconds.
What?
It goes over 100 miles an hour in 6 seconds.
I don't remember the number, but I know the name of it. It's a small robot called Mimo from Honda, a robotic lawnmower. But I will show you the point you spoke about in the area coverage.
With the Honda quality you expect and trust. Mimo is fully customizable to your...
I will share the screen. Did you see it?
yard, your life
Did you see it, Matt?
Yep.
style. Just tell Mimo when and where to mow, and it does the rest.
Here they get a wire around the
Automatically returning
the
to its
borders.
docking station. Your Honda Mimo dealer will conduct a yard survey and set boundary wires around your lawn and existing landscaping, such as trees, flower beds, ponds, and outbuildings, so Mimo knows exactly where to mow and where not to mow. As a decidedly high-tech device, Mimo is autonomous and can be programmed with 3 cutting patterns to suit your needs.
Here is the part.
Random for large open areas, directional for narrower obstacle-free areas, or mixed for large complex yards. Plus, Mimo
This is the part I remembered when you talked about area coverage. You want to continue the video?
That's neat.
What?
That's a pretty cool looking robot.
I will continue it.
and can be programmed to automatically adapt to the season and grass growth rates, delivering the best cutting finish for your yard. Mimo can even detect thicker grass areas, activating its spiral cutting pattern to tackle these zones, while its edge cutting mode will keep the boundary wire area looking neat. Mimo mows frequently, shaving tiny pieces of grass, so your yard is always well maintained and manicured. And it's good for your grass too. Those tiny pieces fertilize and promote a healthier lawn. And because Mimo is electric, it's quiet and can be programmed to run day or night. So in addition to being efficient, it's also stealthy. With its 360-degree awareness sensors, Mimo can work safely and securely. It continually monitors for boundary wires and can detect any tilting or lifting motion, automatically stopping its blade. And if Mimo's bump sensors detect any obstacles in its path, Mimo will change directions and then keep mowing. Worried about theft? Don't be. If someone picks up Mimo, an alarm sounds and Mimo stops working until you enter your custom PIN code.
We will build, if Allah allowed, we will build a user interface on board in the robot like this one, that have a start button and a stop button. And here we will start with simple indicators. One for the robot is ready, and the second one, the robot need to be charged. The third one, the robot is charging when it is connected to the charger. We will make this part if Allah allows.
It's easy to learn more about Mimo's two available models: 3 cutting patterns, specially designed blades, 360-degree sensors, automatic charging system, and day and night modes, all making your life and your lawn care easier. Just visit our website or talk to your authorized Honda Mimo dealer. So,
But I want to ask something, just a second.
autonomous mowing.
I want to ask something. How is the algorithm of covering all this area? I know you get you make the robot to know the borders of this land or this part of land, and and I can't imagine the algorithm to cover all this area. I think it will be like iterationally or something like needs machine learning or what. I can't imagine this algorithm to cover all this area.
We will work in it, Omar. Don't be hurry. Don't be hurry.
Yeah, I'm not rushed, but I'm thinking, just thinking, like in this video, it goes like this, something like this, كده, and something. I think it must be having learning algorithm.
Sure. Matt can talk about this.
Yeah, I need to know about this.
It's magic. I don't know.
Let's stop the record.
You want to see Honda just broke a world record with their new lawnmower.
What?
What?
Honda just broke a world record with their lawnmower.
Yeah.
I posted the link in the chat. Their lawnmower can go 100 miles per hour in 6.2 seconds.
Wow.
Its top speed is 151, I think. Right around there, 150 miles an hour. that will mow your lawn really fast.
In our case, it is easier than the mowing case for Honda.
Let's
Our case,
target
we
the one
have
case. Let's target it in the fifth version of Doodoo.
when I started thinking about agriculture robotics, was the first robot to think to do one like it. I started thinking in this robot 2 years ago, the Mimo robot, and I worked to design a robot like it, a robotic lawnmower of the same size, but I stuck
Why?
due to fun.
Because I wasn't with you. Just I wasn't with you.
Sure. There is another robot of the same concept in this track. They build a wire around the land, and after that, the robot uh, do the algorithm to cover the area. The many robots of the same concept exist. I wonder how how you Matt didn't hear about them before.
Yeah, it's like the Roomba
Yes,
but
Roomba
just
and
outside.
the garden.
Yeah,
Yes,
I think it's a good approach. I think it's people like it. It'll be useful.
sure. But the cost is the main factor. If the robots, Roomba, many robots, I don't remember the number, but a huge number of Roombas were were sold.
Yes, very
Due
popular.
to, yes, due to its low cost. That
Yep.
is the main concern for people. Reliability, as I learned from the CEO of North Star Robotics. He told me that reliability and ease of use are the, the value in agricultural robotics.
Smart.
Yes. Many robots exist. Also, John Deere built one, a small one.
Yes.
Uh, you can search on it, or if you like, I can share the link.
Husqvarna has one also.
What?
There's a company called Husqvarna.
Yes. Many robots exist of the same size and the same concept, and they are about 4 years old or 5 years. I don't remember, but they are new. Yeah. Not completely new, but they are. I think they are adapted in many tracks. When you worked with the GPS, how did you connect? What was the hardware or the connections you made on it?
It's just a USB connection. And then use the GPS ROS node, the NEMA NavSat driver for the software.
Only this.
Yep.
The GPS I have I remember that I told you before that it is communicating using RS-232 and it uses a chip called Max 232 also. I will show it to you. This is a chip. It's called Max 232, and the GPS itself is communicating using the RS-232. This one. It's called Skylab SKM 55. I shared it to you before, but
Does it
it
have
didn't work today.
Does it have a USB cable?
No, a standard
Serial.
connector. I don't remember its name, but I will get.
So you can. This is RS-232 on this side, and then this side is USB. So this is like a converter.
I know that, but the end of the GPS, I will show it to you. Not this block. The DB 90. I will show it to you. You see that?
Yep.
It is this connector, microfit 3 connector. Not a USB and not the DB9.
Yep.
It is this one.
Microfit.
Yes. 4 wire, the VVC and the ground TX and RX. And the TX and RX are communicating using serial RS-232. The chip Max 232 converts it to the TTL to communicate with Arduino. But I need to search more in that to know where is the problem. If Allah allows.
Yeah. This is the same setup. This is a TTL to USB on this side, and then TTL on this side.
Yes, I know that.
I think same chip that you're using.
Max 232.
I think so. Small.
It didn't work. I don't know why, but it didn't work today. It gave 0 readings for the latitude and the longitude. How many readings did you get from the GPS?
Yeah. So I have one GPS that is it's around here somewhere. One per second. Another GPS I have does 10 times a second, 10 hertz.
10 hertz. Okay. That's all we have. Another one. The robot I shared in the random channel for that was open hardware open source hardware and software. Did you see it?
The European country? What was the link about?
What?
What was the link about?
An open source, open hardware and open software robot
Yeah. I
for
emailed
weeding.
them.
I
Yeah,
published it.
I like that robot. It's pretty neat. I emailed them, but I haven't heard back from them yet.
That is the last point I'd like to mention. I forget its name. It's ROMI.
Yeah, roaming.
I published it in general. That's all the picture from our headquarters.